Good morning. My name is Nicoletta and today I will present insights from a global review of the BIM execution plan. First, I would like to introduce myself. I am an architect with an MSc in Sustainable Design and I'm currently researching a PhD in the UCL University in the UK. I'm also the founder and director of BIM Design Hub, an educational center with a focus on CPD certified ISO 9650 courses and Autodesk training. BIM Design Hub is a member of the CPD certification service in the UK and a partner with BSI and the platforms of Plannerly and BIMobject. I'm also the owner of the blog Break with an Architect, where I share industry insights that support the digital future of the construction industry. The presentation today is based on a global peer review publication on the BIM execution plan as part of my PhD study in the UCL University. The paper was published in 2022 in the Proceedings of the Institution of Civil Engineers in the Smart Infrastructure and Construction Journal. Although the review includes both a literature review and a quality content analysis from 36 selected publications, today I will present only the content analysis of the selected publications. In the figure, we can see the frequency of the 36 review BEP documents per year of publication. 13 documents are from academic institutions, 13 are from government construction authorities and agencies, 4 are from industry professional organizations, associations, 3 are from national standard agencies, and 3 are from private companies. The table shows the selected BEP publications and associated BIM guides. The majority of the documents are based in the US, and the rest of the documents are from Finland, China, Singapore, Norway, New Zealand, Canada, Ireland, Australia, and the UK. The figure shows a percentage of the 29 topics occurrence over the 36 documents. The analysis reveals that the topics with the highest occurrence, over 70%, are the BIM goals, the roles and responsibilities, BIM deliverables, archiving record, LOD specification, coordination meetings, data formats for transmission, and file naming conventions. The topics with the lowest occurrence, under 40%, are the hardware, process maps, legally binding, and prescriptive. In the figure, we can see a categorization of the review documents' content types that forms a thematic framework for the BEP development. The framework lists 5 major categories: the functional, informational, technical, organizational, and legal issues. Following, I will present an analysis of the framework categories. The figure shows that the influential dependencies between the categories in the framework. The review shows that functional issues determine the rest of the issues in the framework. In addition, the informational issues form the link between the functional and the technical, organizational, and legal issues and should be considered the core content of the BEP by the BEP developer. For example, for achieving sustainability targets, the BIM use of the energy analysis is required, that is a functional issue, and also the specific information related to the daily weather data and national and local building energy standards. The BIM use is then placed in a process map that results in the data exchange through the CDE, that is an informational issue. In terms of the BIM roles and responsibilities described in the BEP and BIM contracts, the organizational and legal structure determines the access to data exchange and defines responsibilities for the input and data analysis and the owner's approval mechanism. Following, I will present the analysis of the functional issues content types. In the category of functional issues, the first content type is the BIM goal and uses. 32 of the 36 documents contemplate the definition of the BIM goals and uses. However, they vary in the depth of analysis they describe. Some focus on the project goals in connection with the potential BIM uses based on a priority sequence, whereas others require BIM uses to be documented in a separate document and not in the BEP. The review shows that the traditional design build, and integrated project delivery are the three most common procurement methods used in the documents. The analysis also shows that the BEP development can be aligned with the chosen delivery strategy. For example, a design and construction BEP is recommended for the design build strategy, whereas one BEP is considered sufficient for the integrated project delivery. The topic of BIM accuracy refers to information richness and actuality of the data to fulfill their purposes. The review shows that there are two main approaches in the industry: the reference level of development by the BIM Forum and the level of detail and level of model information by BSI. However, the problem of the different interpretations of the LOD in the industry could be minimized by adopting the Level of Information Need framework that is a European standard which aims to normalize the quality, quantity, and occurrence of information developed in a BIM project. Although the topic of BIM capability is not extracted from the reviewed documents, it is significant to include it under the category of functional issues. The proposed BEP methodology, in terms of how suitable a BEP is for a project, has been considered in several BIM capability frameworks. We can see the frameworks here in the images. BIM capability and capacity are also a requirement of ISO 9650 as part of the pre-appointment BIM execution plan. Next, I will present the informational issues content types. The topic Access Shared Data refers to the use of a Common Data Environment, CDE, and is included in half of the reviewed documents, but not with the same description. The review shows that some documents follow the CDE collaboration structure defined in the BS 1192 that was transferred in ISO 9650, whereas others describe an internal specific file sharing system to share project data. The topic Model Strategy division occurs in 15 of the 36 documents, and its description differs in the publications. The model division usually depends on the size and phasing of the building and could include separate parts, zones and levels, and it can be also developed on a level-by-level division, or the floors can be split into zones to reduce file size. In other cases, the model containing hierarchy is dictated by the software used or is based on separate discipline models. The copy topic occurs in 24 of the 36 documents in the review. Some documents define copy as a BIM and facility data requirement, but provide no specific information, whereas others require specific worksheets and a copy drop schedule to be developed across the major project phases. The use of the IFC standard as the data format for transmission to ensure interoperability and as a BIM deliverable format is highlighted in most of the documents, confirming the need for a universal, standardized approach to information exchange between different software. The review also shows that only 14 documents include process maps. although process mapping is generally acknowledged as a means to clarify workflows in a BIM project. Some documents follow the development of process maps in compliance with the Information Delivery Manual by Building Smart that documents the team's strategy to specific project requirements and performance goals. Others align with the Pennsylvania University Guide process maps to describe information exchanges and the process flow. The topic of the collaboration plan has a high occurrence in the review documents, but only a few documents include a detailed description. A collaboration plan may be captured in a three-step diagram, including model creation, model coordination, and frozen and released models, or it may include 5 major areas: document, bid, construction, and cost management, and the project closeout. The review also shows that 29 documents include collaboration meetings, some require mandatory meetings, whereas others require only class detection resolution meetings, and in addition, meetings could be type-specific, such as the BIM requirements kickoff, the BEP development, the design coordination, and the construction over-the-shoulder progress reviews, or could be BIM key stage commencement meetings that review progress. Most of the review documents define information exchanges as models in both native and IFC formats. The Information Exchange Worksheet captures information exchanges at 16 of the 36 review documents and is being developed according to the model uses or to its discipline. In other publications, the information exchanges are not defined in the PEP, but in the employee's information requirements and the master information delivery plan. Next, I will discuss the organizational issues content types. In terms of the document update procedures, half of the publications acknowledge the need for the continuous development of the BEP during a BIM project, and 22 require the owner's approval when a change occurs. ISO 9650 Part 2 provides a list of prerequisites for updating the pre-appointment BIM execution plan after the appointment, so that the BEP can be used by the delivery team to produce, manage, and exchange information. The definition of roles and responsibilities occur in 29 of the 36 documents. 35 different BIM titles are used in the publications, with a structure that follows a similar hierarchy with some differences in the terms used. With a simplified view, the BIM manager leads the project, the discipline BIM lead manages a specific discipline, and the model element authors create and manage the models. In terms of the leading role of the BIM manager, the title of the BIM manager is the most frequent title used in the documents, but the responsibilities are not equally defined. Almost half of the review documents include software specifications, while most of them are vendor neutral and suggest software that complies with the industry foundation classes. Some publications include a list of approved software for BIM authoring, collaboration, and class detection, and others require a specific BIM model type, such as the Revit file for all the BIM authoring software, and the Navisworks viewer for reviewing the 3D BIM models. Next, I will present the technical issues content types. Almost half of the review documents incorporate modeling guidelines and model minimum requirements, highlighting the need to adopt a structured approach at the early stages of a BIM project. The guidelines may include discipline model guidelines, model setup requirements, model coordination, BIM modeling, and 2D drawings. The minimum requirements may include BIM use cases, discipline models, site building and system models. Although the topic of file naming appears in 26 documents, it is not defined equally. Some documents require specific file naming conventions in line with the industry standard BS 1192 or ISO 9650, whereas others develop internal file naming guidelines. The BIM deliverables topic has the highest occurrence among all the topics in review. The BIM deliverables can be either captured in a schedule in the BEP, or they can be listed in the task and the master information delivery plans as defined in ISO 9650. The review shows that the quality control strategy appears in 24 publications. The quality control strategy may include modeling control and assurance checks, visual chain checking, intersection and class detection, standards and model check, automated BIM checks in line with exchange information requirements, or the quality assurance guide. The BIM archiving record topic occurs in 29 of the 36 documents. This topic refers to the construction of as-built models delivered to the owner at the end of the project and includes graphical and non-graphical information related to the asset. The construction of as-built models can be archived in native and IFC formats, or they may be print files in PDF or TIFF formats, to avoid creating an excessively large file. They could also be provided in a digital form that allows information to be easily retrieved by anyone with basic computer skills. The final construction record is also ensured using construction record modeling tolerances by the task teams. Following, I will discuss the legal issues content types. The review highlights the need to address legal issues in BIM contracts and their relationship to the BIM execution plan. From the 36 documents, only 13 are legally binding and prescriptive. The BIM contract protocols, such as the Consensus Docs 301, the American Institute of Architects document E203, and the Information Protocol by the UK BIM Framework, define clearly that each party owns its personal contribution and provide a comprehensive intellectual property license procedure over other contract documents. The topic of the ownership of digital data occurs in 21 documents. The review shows no consensus among the publications on this topic. For example, the ownership of the model author is limited to the duration that fulfills the scope of the project, while the project participants own the copyright license of their contribution and do not possess rights in a model. In addition, the BIM model may be considered an instrument of service defined in the contract, or the BIM and CAD files are not contracted documents, and they should not govern instead of them. The topic of security of information is not extracted from the review documents. However, it is considered a vital issue in BIM information exchange and management, with potential legal implications, and therefore it is included in this category. ISO 9650 Part 5 outlines recommendations on policies, people, processes, and technologies for securing data sharing in projects via collaborative platforms. However, the standard does not address the cybersecurity requirements of collaborative BIM platforms in particular. The reported challenges are the lack of cloud-specific standards for interoperability, data interdependency, and data access and security, and that cybersecurity measures that could become an obstacle to collaboration due to the nature of data storage, meaning the federated model. In addition, research highlights that within the BIM servers, there must be provisions for data ownership, data sharing, federated model creation, and information workflows. There are also two frameworks, an encryption strategy-based framework to facilitate secure storage and distribution of BIM, and a blockchain-based framework to record BIM changes and for the non-trusting environment of construction projects. Finally, I will close the presentation with an overview of the BIM certified training offered by our center. The training is based on ISO 9650 Part 1 and 2, is self-paced, delivered through an educational platform with a rich learning environment. The courses are certified from the CPD certification service in the UK, and I'm also proud to say that our training has been on the shortlist of the European Excellence Awards 2021. Our training also includes 3 short courses on the topics of the BIM execution plan, asset information requirements, and copy basics for SMEs. Thank you for your attention.